Good morning. I'd like to summarize what we read yesterday in class, beginning on page 248. If you open up your textbook and you follow along with me, it'd be a lot easier to follow what I'm explaining as we look at the pictures and we look at the different charts presented to us in the book. We're talking about how atoms differ from one element to another. And as we start on page 248, it talks about the parts of the atom. We know atoms are made of smaller particles called protons, electrons, and neutrons. And our project this week is going to guide us through those particles. Protons and electrons keep an atom balanced. So most normal atoms of any element are balanced, meaning there's the same number of protons as there are electrons. Most normal situations, the neutrons equal the protons. So you have the same number of protons, electrons, and neutrons in most normal elements. The big key, the thing to remember as we talk about the particles of an atom, the number of protons identify which element it is we're working with. So when we say that the number of protons, that's what identifies the element. The number of neutrons and the number of electrons can differ. That's why I keep saying that when we're talking about a normal atom for a normal element, the protons, neutrons, and electrons would all be the same. There are some variances of those though. But in order to identify the element, and I cannot say it enough times, in order to identify which element it is we're working with, you look at the number of protons. So yesterday when I had everyone come up to my desk and you all drew a number out of the cup, that number that you drew, and I recorded in my grade book, that identifies the element you're going to be working with for our project the remainder of this week. If you drew the number 8, you have 8 protons. If you look at the periodic table in the back of your book, you would look and you'd find the atomic number 8. The atomic number identifies how many protons are in the atom. So the number 8 protons would identify the element of oxygen. If you were the number 8, you would be working with oxygen for the remainder of the week. We'll go into that in more detail as we unveil the project we're going to work on starting later today. I say a normal atom because sometimes the numbers differ. The neutrons are not always the same. The first variance we're given is an isotope. If an atom has a different number of neutrons than it does protons, it's considered an isotope. On page 250, up at the top, it gives us examples of a carbon atom. The first column shows carbon-12. Carbon-12 has 6 protons plus 6 neutrons, giving it an atomic mass of 12. However, it also gives us carbon-13 and carbon-14. The difference being carbon-13 has 7 neutrons, carbon-14 has 8 neutrons. Right in the center of that chart, it shows the abundance. 98.89% of all carbon atoms are your typical carbon number 12. There's just less than 1.11% that have 7 neutrons in the atom. That would be the carbon-13. And less than 0.01 or less than 1/100th of all carbon atoms are the carbon-14. So what we do is we take all these possibilities, carbon-12, 13, 14, you add them all together and you divide it by all the carbon that there is in the world. Of course, scientists have to estimate this depending on how many carbon atoms they find in different places. And when they do this formula, they take the number of protons plus the number of neutrons. That gives them the mass number. They take the mass number of all of the isotopes and divide it by the abundance of each element. So the second number we're introduced to is the atomic mass, the average atomic mass. You take all the protons, all the neutrons, you add up all the possibilities of the isotopes, and you divide it by the abundance. Luckily for us in 8th grade, we don't have to do that, but we do have to understand what the average atomic mass is. It's the average of all the different types of atoms of that particular element. So if we look at the chart, you see the average atomic mass for carbon is 12.01. That gives you an idea that most carbon you find is the typical carbon number 12. Radioactivity is when an unstable element is emitting particles trying to regulate itself, to become stable. It can emit protons, it can emit neutrons, it can emit a combination of the two. It's just trying to get rid of energy so that it can stabilize itself and not be so volatile or unstable. Certain elements are more radioactive than others, meaning that they're more likely to emit energy which could be harmful to humans. You heard of different explosions throughout the world at nuclear reactors. The explosion of Chernobyl over in Russia. That was over 30 years ago, and scientists are still trying to evaluate the long-term effects of that explosion. It's been quarantined, it's been barricaded. Just within the last year or two, they've started letting a handful of scientists go inside and see the changes of the life as an effect of that explosion. Last but not least, on page 254, it gives us a quick introduction to ions. Ions are the result when an atom gains or loses an electron. The protons stay the same, and remember, an element is identified by the number of protons it has. So if it has a different number of electrons, it's an ion. It's the same element, but it has a different number of electrons. So if a typical atom has the same number of protons and electrons, we can say that's balanced. They cancel each other out, so to speak. But if it gains or loses an electron, it's going to be a positive charge or a negative charged ion at that point, depending on whether it gained or lowered. So just like you use math counters in math class, depending, as the bottom of 254 shows you, you line up the number of protons and the number of electrons. Whichever one has the most, that would be the charge that that ion would have, a positive or negative ion. Okay, so what I'm going to do is, after this video, I'm going to show you one more video. It's from a sitcom that played back in the late 80s and early 90s called WKRP in Cincinnati. A guy gives a visual to explain the parts of an atom. Talks about the protons, the electrons, and he uses a little bit of gang slang to connect it for somebody that didn't understand atoms. So I'll show you that, and then we're going to transition into our project. If you look up on Classroom, I upload the rubric that we're going to follow for this project. You're going to work with the element that you drew out of the cup yesterday. So you need to do some research, and you'll have to access this rubric to guide your research. Questions such as, how was the element discovered? Who discovered it? Where was it found? What did they use it for primarily? And that could be back in the original time. What did they use it for back then versus what is it used for now? Your research can take you very shallow up on the surface, or you can dive in very deep and find some good quality stuff. It depends on how much work you're willing to put into it. But I will say that this project is worth 100 points. So it is a form of an assessment, but it's not like a test where you don't have a chance to put in some good quality effort and find some good research that you can share with the rest of the class. What is the atomic symbol? You should find that on the periodic table. When you look up to see what element it is you're working with, you will also see the atomic symbol, or the abbreviation that they use for it in science and chemistry classes. Describe the state of matter it is most common in. Is it most commonly found as a solid, a liquid, or a gas? And I caution you because it may be used in a certain state of matter if scientists change what temperature it is they're working with that element. But how is it usually found when they first access it, when they first discovered it? What state of matter was it in? A liquid, a solid, or a gas? And does it have a different use in its different states? Eventually we're going to transition. You're going to create a model of the atom. You're going to have to come up with a drawing that is creative and unique. It's colored. It includes a key telling me what are the different parts of the atom, the protons, the electrons, and the neutrons. Figure out a symbol so that when you're drawing that on your model, your key gives representation of what those different symbols represent. You're going to include examples on the side of the drawing for the atomic number and the average atomic weight. So make sure you include those things. They should all come off the periodic table. Most of your research is going to be conducted up in the Discovery Research box at the top of the rubric. The rest of the stuff is just parts of the model that I'm looking for to show that you understand the different parts of an atom and the atomic model that we're supposed to develop. Once everyone gets finished, we're going to present our models to the class. Nothing to fret over. You're basically going to walk them through number of protons, neutrons, electrons, what is the atomic mass, and share with us the research that you found. So all of those together will add up to 100 points. You can access that rubric on YouTube. And I'm going to show you Venus flytrap. It's the YouTube video that I'll also upload on Classroom so you have it to refer back to. You'll have the next 2 days to work on your research and your atomic model. So don't rush through it. We're looking for quality. If you want to rush through and slop, your grade's going to reflect that. Take your time, do the research, use what time you have left today, tomorrow, and then Thursday we'll focus on getting everything wrapped up and finalized. So any questions, make sure you talk to me, talk to Mrs. Baldwin or Mrs. Fisher, Miss Ashner. We're all here to help. This is what we're going to do the rest of the week, and then enjoy Homecoming Friday. So peace out.